Okay, so we've recapped all of the notation about inequalities, the symbols we use. We've talked about drawing them on number lines to give a visual representation of an inequality. And we've talked about solving linear inequalities and how closely connected that is to solving linear equations. So the final step in this process is to draw an inequality on a graph. This is sometimes referred to as regions, and you'll see why in a minute. And this is really closely connected to just drawing straight line graphs in general. So all I'm going to do is I'm just going to work through a few examples. There's a really straightforward step-by-step process for this. It's actually basically just drawing straight line graphs with a little bit extra on top, a lot like the equation stuff was. So what we have to begin with is, here's our question at the top. On a set of axes, show the set of values that satisfy the inequality, and then our inequality is x is less than or equal to 2. Now, before we can begin doing anything, we have to answer ourselves a question. And it's a bit like when we were drawing them on the number lines, whether we were going to fill in or leave empty our circle. In fact, it follows the exact same logic. And the question is, do I want it to be solid or dotted? Solid, as in a solid straight line drawn, we will do in this case because we have the equals symbol on our inequality. X is allowed to be equal to 2, so in this case we're going to draw it solid. If x wasn't allowed to be equal to 2, and we'll see that in another example, we would draw the line dotted instead. So step 1 is a simple question, solid or dotted. Answer is solid. Step 2 is draw the line. Now what line do we draw? Well, we draw the line as if it just said equals 2. Ignore the inequality. How would we go about drawing a line of x equals 2? So we need to find some places on our graph where x equals 2. So for example, just here on the axis, the point 2, 0, but also heading upwards is also equal to 2, and so is heading downwards. We have this nice straight line here of all these points. Now, once you get practiced at this, you don't need to plot them, although it is always a fairly good idea to plot them. And then all we do is we just draw in a nice straight line, preferably with a ruler. And because our question number 1 was solid, we just draw a solid line. Done. So step 2 is draw the line. Step 3, this is where the difference comes in. And step 3 just says test which side of the line. Now what I mean by test is just pick a coordinate. It can be anywhere on the grid as long as it is on one side of the line or the other. On the line is not going to help us. We need to pick a point on one side of the line or the other. So I'm just going to pick, this point right here. So I'm going to pick the coordinate 4, 2. And I'm going to just test it in my inequality. So the x coordinate's 4 and the y coordinate's 2. So that gives me, my inequality is x is less than or equal to 2. So this is saying 4 is less than or equal to 2. Now, is that true or false? No, that's wrong. Okay, because 4 obviously isn't smaller than 2. So this point on the right hand side of the line, I don't want that point. So what we're going to do now is we're just going to cross out the section that we do not want, because this side of the line, none of that side is going to follow the inequality. And then we just need to do one final thing. We need to really clearly label, usually with a big capital letter R, the section of the line we do want. And this is called the region of the graph, hence the alternative name to the topic, which is wanted. Okay, so that's the first one done. We know it's solid, we drew the line, we tested a point and then crossed out so that we had this region. So let's look at a second example. So for our second question, the only thing that's really changed is our equation, or inequality, which is now y is less than -5. So let's just run through the same steps. Is it solid or dotted? Well, this time it doesn't include the line, the equals line, so we're going to draw it dotted. A dotted line will tell us it's not allowed to be on the line, it has to be one side or the other, whereas the solid line told us we could be on that line last time. Step 2 is draw the line. So remember, we're drawing as if this was an equal sign, not an inequality. So we're trying to draw y equals -5. So let's just plot some places on the graph where that's true. So we're just here and here and here. These are the points where y equals -5. Okay, hopefully you're familiar with that. And then I need to draw that with a ruler, but it needs to be dotted. It's not the best straight line ever, but I am trying to do this on a computer. So this dotted line here is kind of the edge of our inequality. And the final thing we need to do is to test which side. Should this be above or below the line? I'm going to pick a point below the line this time. Let's just test out this one down here. So this point is 4, -8. Okay, that's the point I've picked. So I just need to substitute these numbers into my inequality. My inequality says y is less than -5. Y is -8 on my point. So -8 is less than -5. Well, that is definitely true. So actually the section I want is the section below. So what I need to do is I just need to cross out the stuff above the line. I don't want this stuff because a point below the line followed the rule, which means a point above the line must not follow the rule. So all the stuff I want is below, and just like we did before, I then need to add in a nice big letter R just to make it really clear that this is the region I want, the one below the line. I've crossed out what I don't want and I've kept what I do want. One more simple example. This is a little bit more awkward because my equation for the line is a little bit more awkward, but we'll run through the same steps. Solid or dotted, there's no equals line, we want it to be dotted. Draw the line, I want to draw y equals x. Swap the inequality for an equals sign. I now need to plot the line y equals x. Well, there's a handful of different ways of doing that. You might prefer to draw a table of values, maybe from -2 up to 2, and find your y values. You might recognize this in the form y equals mx plus c and find your gradient and y-intercept and draw it that way. Or you might just kind of pause and think logically about it and find some places. So if y has to equal x, that means my coordinates need to be, well, pairs of the same number, like 0, 0, or 2, 2, or 4, 4, or 6, 6, or -2, -2, and so on. This is actually this diagonal line, and it's a really common line to see. It's not a big surprise to come across this line in an inequalities question. So I just need to try and draw a diagonal dotted line, a nice straight one, which is easier said than done on the computer. Ooh, I've done an appalling job of that, but hopefully you can do a slightly better job on a paper with an actual ruler. And now I just need to test which side, so we need to pick a point. Let me pick something with a negative in this time. So let's go with this one. So I'm testing the point -2 and 4. Now the testing's a little more awkward here because I've got x and y. So my equation said y needs to be greater than x. In this point I've picked, y is 4 and x is -2. Well, is 4 bigger than -2? Yes, that is definitely true. So I want the section with my point in, so I'm going to cross out the other side of the line, and I'm going to label the section we want with a big capital R. Sorted. Those are 3 very simple examples. Let me just run you through one more. This is more like what you'll see in an exam. So for this final question, we've got, well, a bit more work to do. So instead of just having one inequality to draw on the graph, I've actually got this one here, and this first one actually splits into 2 different inequalities. So what we're going to do is I'm just going to jot them all four down as separate things. So I've got to sort out -8 less than or equal to y, and then I've got to sort out y less than 6, and then x greater than or equal to -9, and then y greater than 2x subtract 8. For each of them, I'm going to work through these three steps. 1, 2, 3. Solid or dotted, how am I going to draw the line, and then test which side. Actually, what I'm going to do is I'm going to show you steps 1 and 2 for all of them, and then we'll do the testing and shading. Which I would probably do this in this order each time, but it's going to be a bit easy to show you on here. So, solid or dotted, this includes the line, so it's solid. This one doesn't have the equal sign, so it's going to be dotted. This one is going to be solid because it does include the equals line, and this one is going to be dotted because it doesn't include the equals line. First question is easy to answer. The second thing we're going to do is we're going to plot these as if this is an equal sign. So where is y equal to -8? That's going to be down here, going to the left and to the right. Where is y equal to 6? That's going to be up here, just the same, a horizontal line. Where is x equal to -9? This is going to be, x is -9 over here and going upwards and downwards. It's a nice vertical line. And then the final one, a little bit more awkward, y is going to be equal to 2x minus 8. So we might, for this one, do a quick table of values. If x is -2, then 2 times that is -4. Subtract 8 is -12. That's actually off our graph. If x is -1, then 2 times -1 is -2. Subtract 8 is -10. We've got a point now. 0 take away 8 is -8. 1 times 2 is 2, take away 8 is -6. And then 4 take away 8 is -4. And I could keep going, but actually I've got enough here to plot this. So at -1, -10. At 0, -8. At 1, -6. And at 2, -4. And you can kind of see this line is going to just keep going up like this. We could find some more points, but we don't really need to. You could also do this by knowing that the y-intercept is -8, so I start here, and the gradient is 2, so I kind of go across 1 and up 2 in terms of my gradient. I am not going to attempt to draw all those straight lines on myself on the computer. I've done that already. So this gives us these 4 lines. We know whether they're solid or dotted and where they should be on the graph. So all we have left to do is just to do the step 3 test which side. Now when we tested before, we picked a point and we plugged it in and we decided did it fit the rule or not. I'm actually going to make my life a little easier by picking the same point and testing it in exactly the same way every time. And it's convenient to pick a nice easy point. So I'm going to grab this guy right here, the coordinate 1, 1. So x is 1 and y is 1. I'm just going to go through these lines one at a time. I'm going to try it out and see whether it follows the rule or not. And if it follows the rule, I'm in the right place and I cross the other side of the line out. If it breaks the rule, I'm in the wrong place and I cross out the side where my little x is. For the first one, I want -8 to be less than or equal to y, which is 1. And that is true. So I can cross out below the blue line. I'm above it, so I can cross out below the blue line. I don't need that region. For my second one, I want y, which is 1, to be less than 6. Well, that's also true. I'm below the green line, so I can cross out above the green line. Don't need that space. My third says x is greater than or equal to -9. X is 1, so is 1 greater than or equal to -9? Yes, it is. So I'm in the right place, which means the left-hand side of this red line we can cross out, we don't need. And the final one, I need y, which is 1, to be greater than 2x, which is 2 times 1, take away 8. I need to just work this out to make sure. So is 1 greater than 2 times 1 is 2, take away 8 is negative 6. Is 1 greater than negative 6? Yes, it is. So again, I've picked the correct side of my purple line. Being above it's right, so being below it we can cross out. And what that leaves us with is this section in the middle, which I can label with a big R, because that follows all 4 of those rules, and we're finished. So to practice this, there is a task on My Maths which is called Shading Inequalities, which is just this same thing.